First, distance from a point to a line. So distance from a point to a line is always the perpendicular distance from the point to the line, right? So that is length of perpendicular from the point to the line, always same, right? That is the meaning of distance from a point to a line. The distance from a point to a line is the length of perpendicular drawn from the point to the line. The distance from a point P x1 y1 to the line ax plus by plus c equal to 0 is modulus ax1 plus by1 plus c by root of a square plus b square. We'll see the proof. So method 1, let small d be the distance from the point P x1 y1 to the line ax plus by plus c equal to 0. Draw a perpendicular from P x1 y1 to the line ax plus by plus c equal to 0, which meets the line at M. So x dash x axis, y dash y axis, O is the origin. So this is the line ax plus by plus c equal to 0. Let P x1 y1 be any point, right? Draw a perpendicular from the point to the line which meets at M, Pm, which is the perpendicular from P to the line ax plus by plus c equal to 0. So Pm is the required distance, right? Distance from the point to the line, that is Pm equal to small d. So first we are going to write the intercept form of the line ax plus by plus c equal to 0. We know general form to intercept form. The standard result is there, you can write as it is, right? Same. So intercept form means x by a plus y by b equal to 1. A is the x-intercept, b is the y-intercept. So we are going to write this equation in that standard form. So first write it in the way minus ax minus by equal to c. Keep the c one side and take the ax term, by term to the other side. So minus ax minus by equal to c. Next divide the equation by c. Minus a by cx, right? Minus a by cx minus b by cy, which is equal to 1. So this can be written as, so a by b can be written as 1 by b by a. It's reciprocal. Similarly, here minus a by c can be written as x by minus c by a. Similarly, plus y by minus c by b equal to 1. So here x-intercept is minus c by a and y-intercept is minus c by b, right? So hence ax plus by plus c equal to 0 meets x and y axis respectively at minus c by a comma 0 and 0 comma minus c by b. We know x by a plus y by b equal to 1 meets the x axis at the point a comma 0, right? And y axis at 0 comma b. Similarly, instead of a you are having minus c by a and instead of b you are having minus c by b. So let q and r are the point of intersection of the line and x and y axis respectively. So q is the point of intersection of x axis and the line ax plus by plus c equal to 0, and r is the point of intersection of the y axis and ax plus by plus c equal to 0. So the coordinate of q and r. So OQ is the x distance of q, that is the x-intercept of the line ax plus by plus c equal to 0. So OQ is the x-intercept, that is minus c by a. So q is on the x-axis, so y coordinate 0. So coordinate of q is minus c by a comma 0. Similarly, take r. OR is the y-intercept of the line ax plus by plus c equal to 0. That length is minus c by b. OR is nothing but the y distance of the point r. R is lies on y-axis, so x coordinate 0. 0 comma r coordinate is 0 comma minus c by b, right? Now consider the triangle PQR. Draw the triangle PQR. Join PQ and PR, you will get the triangle PQR. So area of the triangle PQR, which is equal to half into height of the triangle and base of the triangle. Here height is nothing but PM, that is D, and the base is QR, the length QR, right? Half D into QR. So D, from that D is equal to 2 into area of the triangle PQR by QR. So we need to find the area of the triangle and the length QR, right? So this is equation number 1. First we are going to find the area of the triangle PQR. So if the vertices are x1, y1, x2, y2, x3, y3, area of the triangle is given by half into x1, y2 minus y3 plus x2, y3 minus y1 plus x3 into y1 minus y2. Here x1, y1 is the point P, right? That is x1, y1 only. And x2, y2 is the point Q minus C by A, comma 0. And x3, y3 is the point R, that is 0, comma minus C by V. Substituting this value, area of the triangle PQR, which is equal to half into x1, 0 minus C by B plus minus C by A into minus C by B minus y1 plus 0 into y1 minus 0. So that is equal to half into minus into minus plus x1 C by B, first term, minus C by A into minus C by B. So minus into minus plus C square by AB. Then minus C by A into minus y1, minus into minus plus C y1 by A. Last term 0 into something 0. So taking C common outside, so C by 2, taking a common LCM AB. So first term AX1 plus BY1 plus C, which is in the numerator, divided by AB, is in the inside the modulus value, right? So this is equation number 2. Next we are going to find the length QR. So we know distance formula. Distance between x1, y1 and x2, y2 is root of x2 minus x1 plus y2 minus y1 square. X2 minus x1 square plus y2 minus y1 square. So here Q is one point and R is another point. So Q is minus C by A, comma 0, that is x1, y1, and R is x2, y2, that is equal to 0, comma minus C by B. Therefore the length QR, which is equal to, substituting this value, 0 minus 0, 0 minus minus C by A the whole square plus minus C by B minus 0 the whole square, that is equal to C square by A square plus C square by B square. So taking A square B square as LCM, so root of C square, A square plus B square by A square plus B square, A square into B square, right? Just cross multiplying. So C square is common, right? So A square, B square and C square, take it outside from the square root. So it will become C by AB. So C by AB root of A square plus B square, that is equation number 3. So from 1 to 3, the distance D, which is equal to 2 into area of the triangle from 2, C by 2 modulus AX1 plus B y1 plus C by AB divided by C QR, the length, C by AB root of A square plus B square. See, in the numerator you are having C by 2, the denominator you are having C by AB, so C and C get cancelled. So 2 is outside and 1 by 2 in the numerator, so 2 into 1 by 2, 2 and 2 get cancelled. Next, AX1 plus BY1 plus C by AB, right, in the numerator. Similarly, remaining term in the denominator, root of A square plus B square by AB. So AB and AB get cancelled. So remaining you are having modulus AX1 plus BY1 plus C by root of A square plus B square, which is to be proved. So next method, let P x1 y1 be any given point, AB be the line, AX plus BY plus C equal to 0, right? So AB can be written as AX plus BY minus C equal to minus C, that is equation 1. So now draw XX dash X axis, YY dash Y dash Y axis, 0 is the origin, line AB, AX plus BY plus C equal to 0, right? Let P x1 y1 be any point, right? So draw the line CD passes through the point P x1 y1 and parallel to AB. So draw CD, which passes through P x1 y1 parallel to AB. Draw a perpendicular from the point P to the line AB, that is the distance between the point and the given line AX plus BY plus C, that is the perpendicular distance PM, right, which meets AB at M. So draw a perpendicular from the origin O to the line CD. So draw a perpendicular, right, O to CD, right, which meets CD at Q, right? So AB and CD are parallel, so this line OQ is definitely perpendicular to AB, right? So which meets AB at R. So OR is the perpendicular distance from origin to the line AB, and OQ is the perpendicular distance from the origin to the line CD, right? So let theta be the inclination of length of perpendicular. Length of perpendicular means OR, OQ are the length of perpendiculars from the line AB and CD respectively. So I am taking OR, or you can take OQ. So same line only, right? With the x-axis, the angle of inclination is theta. So let OR, the length of the perpendicular from the origin, let it be P, small p, and OQ, the length of the perpendicular from the origin, let it be P dash. So required distance D is the length of the perpendicular from the point P x1 y1 to the line AB. So PM, right, that is equal to small d. So we know that normal form of a straight line, right, equation of a line is, right, x cos theta plus y sin theta, which is equal to length of the perpendicular from the origin, that is equal to P. So AB represented by the equation x cos theta plus y sin theta equal to P, that is equation number 2. Similarly, we can represent the line CD also, the normal form x cos theta y sin theta, but length of the perpendicular is P dash, right, that is equation number 3. Now see, AB represented in the normal form x cos theta y sin theta equal to P by 2. But AB equation is, we know from equation number 1, AX plus BY, which is equal to minus C. So comparing 1 and 2, both are same, right? Comparing 1 and 2, so x coordinate of 2 cos theta, x coordinate of 1 A cos theta by A, which is equal to y coordinate of 2 sin theta by y coordinate of 1 by B, which is equal to constant term 2 P and for 1 minus C. So by properties of ratio, cos theta by A, which is equal to sin theta by B, which is equal to P divided by minus C, which is equal to cos square plus sin square theta by A square plus B square. So A by B, which is equal to C by D, then A square plus C square divided by B square plus D square. This is the property. So A by B, which is equal to C by D, which is equal to A square plus C square divided by B square plus D square. We are using that property. So taking first two ratios, so cos square plus sin square divided by A square plus B square, which is equal to taking square roots on both sides. So plus or minus root of cos square theta plus sin square theta by square root of A square plus B square. So this is also the property. If you are taking a square root or squaring or cube, whatever it is, all proportions are equal, right? This is the property of ratio. So we are taking square roots. That is why we are putting plus or minus, because suppose we know x square equal to 2, x is equal to plus or minus 2. So it's same thing. So cos square plus sin square is root 1. So root 1 is 1. So this is equal to 1 by plus or minus root of A square plus B square. So consider cos theta by A, first one and the last ratio, equal to 1 by root of A square plus B square. So plus or minus is there. So cos theta is equal to plus or minus A by root of A square plus B square. That is from 4. So consider the second one sin theta by B and last one plus or minus 1 by root of A square plus B square. Sin theta is equal to plus or minus B by root of A square plus B square, right? This is 5. 4, 5 equations, right? So now consider the last one. P by minus C is equal to plus or minus 1 by root of A square plus B square, which is equal to P, which is equal to plus or minus C by root of A square plus B square, 6. Since Px1 y1 lies on 3, Px1 y1 satisfy the equation x cos theta plus y sin theta equal to P dash. P lies in the line CD, but CD is represented by the equation x cos theta plus y sin theta equal to P dash. So P satisfy the line equation. So put x equal to x1, y is equal to y1 in that equation. So we will get x1 cos theta plus y1 sin theta is equal to P dash. That is equation number 7. The required distance D is equal to PM. That is nothing but QR. So QR can be written as OQ minus OR, right? So OQ we know P dash minus OR which is equal to P dash minus P. So using 6 and 7, the required distance D is equal to P dash minus P, that is equal to x1 cos theta plus y1 sin theta. So P is plus or minus value is there. So minus into plus, minus, minus into minus, plus, again you will get plus or minus C by root of A square plus B square. Using 4 and 5, the required distance which is equal to plus or minus x1 into A by root of A square plus B square plus y1 B by root of A square plus B square plus or minus C by root of A square plus B square. So root of A square plus B square is common LCM. So you will get plus or minus ax1 plus by1 plus c divided by root of a square plus b square. Plus or minus is also common. So plus or minus means you can write it as in the modulus, right? Therefore required distance D is equal to ax1 plus by1 plus c divided by root of a square plus b square in the modulus, which is to be proved. So first note, the perpendicular distance from any point P x1 y1 to the line ax plus by plus c equal to 0 is D is equal to ax1 plus by1 plus c divided by root of a square plus b square, say modulus value. Second one, the perpendicular distance from the origin to the line ax plus by plus c equal to 0 is only the constant term, modulus of constant term divided by root of a square plus b square. Thanks.